Hello, everybody. Welcome to another episode of the Obsertelligence podcast. My name is Belyadi. We have another special guest with us today, Dr. Salah, and I'll read his bio prior to going and discussing some very important questions about deep learning today with Dr. Salah. Dr. Salah is an accomplished research scientist and entrepreneur with over 5 years of experience in energy industry, mainly focusing on digital transformation and product development in unconventional treatments, sustainable natural resources, and renewable energy system. Dr. Faroughi holds BS and MS in mechanical engineering. He obtained his second MS in geofluids and his PhD in geomechanical engineering at Georgia Institute of Technology. Dr. Salah did his postdoctoral study in the Department of Mechanical Engineering at MIT, focusing on the development of high performance computing algorithms augmented by physics-based machine learning models. Currently, Dr. Salah is a senior R&D manager at Petrolern, a research and consulting firm where he is leading a team of talented scientists and conducting digitalization projects on renewable clean energy. With that being said, Dr. Salah, it's a pleasure and honor to have you on board. Welcome on board.
Thank you, Oz. Thanks for having me.
Yep. So before we get started, I just want to talk to you about, this is the first question I ask during a lot of the podcasts, and it is, what is your overall vision for the future of AI and automation in the energy industry?
Well, that's a very good question. And currently, our industry is experiencing two main transition. On one side, go clean, and the other side, go smart. So, and this is a big move, and everybody in the industry is under the pressure. But it will happen for sure. And here the time is the key. So we cannot rush it. We cannot be smart in 1 year. We cannot be clean in 1 year. For example, all the company came out claiming, hey, we want to be net zero carbon emission by 2015 or 2013. But when they want to be smart, they just claim, hey, we are smart. We do this smart. And those kind of misconception kind of are holding us to the natural course of the development of being a smart company or having a smart technology. Mm-hmm. So, and as you know, because of that impact, so a few years ago, all the giant oil and gas company teamed up with the giant tech company and saying, hey, we are going to be smart. And then at the end, they found, okay, if that permeability that you have is great. If you increase the permeability, you get a lot of production. That was the output. That's not going well. And then from the other side, now everybody in the industry is trying to introduce himself or herself as a data engineer, as an AI engineer. Well, they have a very nice physical background, and they are trying to use very simplified tools like, and algorithms that are designed for something else in our field, just to say, hey, we do AI. For example, take random forest or SVM. Those are very simple algorithms that are not designed for heterogeneous multidimensional data. So, and they are just trying to use those models and just push it and rush it and say, hey, we're good. Hey, we can do it. And that's not actually the problem. So everybody right now hires AI engineers. And so they have to change their title to be AI. If you write proposals, if you write papers, faculty the same too. They have to write proposals and they have to somehow fit AI into their proposal to be accepted in this. And this is good. This is just the start. It takes time, but it takes really time. So far, I think we have not even started the right, the process. So, but let me give you some statistics. Yeah. Only in 2019, more than $2,000 billion were spent on digital innovation, which accounts for 40% of the total spending on technology across the industries. And this number has been increasing quite well since 2015 to 2019, and then also the 2020. So it means, okay, everybody notice, okay, we need to be smarter, and that's, that process has started. So in the course of 5 years, the price of sensor are down by 50%. The price of data storage are down by a factor of 60. For example, the price of processing a bunch of data, a known amount of data is now 60% cheaper. It's interesting to know that 90% of the Fortune 500 company are claiming that they have one solid AI solution in their business running. And it's also very important that that's actually out by McKinsey, that 85% of the managers and technology buyers in the industry right now are millennials who strongly believe in digital solutions. And that's why that has been reflected in the oil and gas industry or energy industry too. They all, okay, we believe, as you believe in digital solution, as I believe in digital solution, then we push that direction, right, towards that direction. So everything has started, and now I have heard from different company in the oil and gas that they have some solutions, AI solution in their system. It could be in their business system, their operation, or scientific, that I doubt it. And then they are saying that they have increase in production 3 to 5%. It's not hydrocarbon production, it's just overall productivity. So these are important statistics. These are telling us, yes, it's possible to go, but we need to be careful when we talk about the application of AI in scientific area. This is different. This is not business. This is not image processing. This is different, because the data either are sparse, we don't have the data. It's not as easy as it can be done for the business case, because you have data, clean data, or as not when you work with video, you have lots of data, right? So we need to be very careful when we talk about the application of AI and the future in our industry. Of course, the future is I'm very optimistic. It's going to be great, but it will take time.
Yeah.
And yes, so, and let me then talk about a little about AI itself, right? AI, the coin formulation that we have is very too simple. If you have a good background in mathematics, you really understand that in the mathematics we have a lot more complex algorithm than what we have, and we have been using them in the past, right? Like, I love finite element. I love lattice Boltzmann. Lattice Boltzmann, in one line, one linear equation, you solve it, right? Just with one line, and then just with some, linkage, very smart linkage, you can solve highly complex and nonlinear PDEs like Navier-Stokes. This is amazing, but the problem with the lattice Boltzmann fine bond, they are all mesh dependent. They are all very heavy. So the good thing about AI is just, they are, easier to understand, to people to grasp it and to apply it. And that's why people are all saying, hey, AI, it's going to be, for sure it's going to be, but not this formulation that we have. Machine learning, like random forest, cannot help us more than what it has done so far. So we need different algorithms. But as companies are pouring money, pouring resources, for sure that's going to happen in the next decade. We will have a lot smarter algorithms for AI, and that can help us to go wherever we want to go. Yeah.
Got it. That's a very good perspective. And one thing, about, AI, is that deep learning, which is a subset of machine learning, has become very popular, especially it's been one of the biggest breakthroughs in AI, and I think part of that is because, we have a lot of data now. We have GPU processing. We have, toolboxes such as TensorFlow that are really helping and making it so much easier to deploy these deep learning models, and there are a lot of applications in different industries, So can you talk about some of the applications of deep learning that you guys have been working on? And how do you think deep learning has impacted and will impact the energy industry?
Okay, let me start this with that. If something is going to happen in energy industry, in the scientific area, it has to be deep learning. Machine learning cannot help you. So let me also give you a very simple, for people to understand what is machine learning and what is deep learning. So deep learning is, of course, a family of machine learning, but let's just, for now, ML is simpler than DL, okay, for two reasons. So ML cannot handle very complex heterogeneous data. Let's say you are going to use the logistic regression or classification, and you want to classify two families with a line in between. If this line is linear or somehow non-linear, yes, you can go with the ML. But if this line is several circles inside each other, then ML cannot help you. You have to go with the neural network, and it has to be DL. And then I will talk about why DL is harder than to train. And then the second, which is the most important part, why DL has got more attention than ML in the recent years, is the fact that in deep learning says, I will take care of the feature engineering for you as well. But for the machine learning, you have to manually go through the features. Hey, this feature should be important. Let's have this feature, and this feature, and now let's train the model. But deep learning will help you to do the feature extraction, feature engineering, as soon as you do a car classification, right? For the ML, somebody has to come, this is four-wheel, four-door, this is Toyota, this is Honda. No, you have to give you all the, but the deep learning will tell you which is which, and it will extract all the features for you. This is the main differences between DL and ML. And then algorithm-wise, they are also quite different. Mm-hmm. Now, in terms of applications, so I foresee, I think there are three main applications that I personally I'm very interested in. First of all, you have a bunch of data and you want to model them, right? And sometimes even in our field, it's hard to get good data, but sometimes we have it. We have very complete data set that we are confident about, and it's non-linear. We cannot use ML, so let's go and challenge them with the DL, right? This is one part. This is the easiest. Everybody can go with Panda, write a few lines of code, train a model. And then the other thing that in energy industry and as a scientist we are facing is that we are using a lot of forward modeling, like as I said, finite volume, Lax Boltzmann, and CFD, and etc. And those forward modeling, it's not just the seismic inversion or weather prediction. They are all forward modeling. They are all slow. And if you go through those algorithms, you see bottlenecks, right, that can be replaced with the AI model. Because either you have good amount of data and you don't want to, solve those nonlinear equations again. So instead of you want to call an AI function to give you what you want, the output that you want. This is where you can speed up the forward modeling. This is another area. And then another topic that it's gonna break through, it's gonna change the way AI will help, is we use them to solve the actual PDEs and ODEs and all the equations that we know for years, and we have been practicing them for years. Whether they are correct or not, I don't talk about that. Of course, they are all simplified, but we have tools to make them more complex. And now if AI can solve them, instead of converting them to data and then model the data, just go and solve the actual problem. Mm-hmm. That's gonna change the way AI is in our industry, especially for the scientific part. For example, and that's not something that has not been done. So recently a paper came out of the Caltech by Anima Group, and they have shown that they can now solve Navier-Stokes 1,000 times faster with a very good accuracy, using AI. So they just take everything to the Fourier kind of space and solve them there and then come back to the physical space. It's a very smart move. That's why I'm saying, if you want to do something in AI for energy industry, this is the way to go. It's not just to use those models that have been developed for gaming industry or for computer vision. We cannot just apply them to our data. We have to go from a different way. And we have been exporting science for years, and there also we need to export our own and we have to develop our own models. And as I said, these three steps I discussed, complex data, speed up forward modeling, and solving PDE, it's not gonna happen using ML. It has to be deep learning.
Mm-hmm. Got it.
Yeah.
So speaking of deep learning and some of the stuff that you touched on, can you also talk about some of the algorithms within deep learning, such as convolutional neural network, which is used for a lot of face recognition and the recurrent neural network, especially like LSTM. Can you touch on those a little bit and briefly discuss the most, popular like algorithms within deep learning, not just in the oil and gas, but in different industries?
Sure. So before starting on that one, just for the previous question, I want to add something. I'm not negative about what we have so far. I'm really positive, and myself I'm using it a lot. But the fact is that in engineering, we don't have that much room to mistake, right? You
Mhm.
cannot, the safety is important. You have to be very precise. For example, you go look at the Netflix, they offer you some recommendation. How much of that is accurate? Honestly, be honest. These big companies spending a lot of money on those algorithms. Just there's a lot. It's less than 50% for me. But in the engineering, I don't have that room to be 50% wrong, right?
Yep.
It's deadly. It's just deadly.
You
So
like
that's
you
why I'm
just don't
saying
have a job.
exactly. It's so. And now, for example, look at the Facebook ad. How much is related to your profile? They are still very behind, and we are using those models, and we want to solve very complex physics. It's impossible. It's honestly impossible. You may solve it. Okay, let me be clear here. You may solve. We have been working together. We have solved a problem using deep learning, but you see that it is very locally. You
Mhm.
can solve it for one location for a very specified controlled environment. If you get out of that environment, the model is not generalized. And that's the problem. And for example, for the Facebook ad, okay, you can just run it whatever it goes, because it's not deadly. It's not a safety issue. It might be, you never know, but it's not deadly at least. But that's why I'm saying, okay, we have to be very careful of what we choose, why we choose them, and what we have to do to make it work in our industry.
Got it. Got it. No, that's a fair point. That's a very fair point. I think that's one of the issues that also Dr. Shah touched on, that solving engineering related problems is different than solving
Exactly.
non-engineering related problems, which is pretty much what you're alluding to here.
Yeah.
So that's very good. So now that you touched on that question, that previous question, can you touch on some of the most popular algorithms within deep learning, such as convolutional and recurrent neural networks?
Sure.
Uh,
So I think most people are really familiar with the neural network, which is the basics of the deep learning.
yep.
It's a fully connected network. Every neuron on each layer is connected to all the neuron on the other layers. It is a fully connectedness. Okay.
Mhm.
And it is prone to be overfitting all the time. So here is the dilemma. Is the fact, is the problem. Training deep learning is really complex. It's a lot more complex than machine learning.
Mhm.
So we have to be very careful not to overfit the data. And for example, RNN and CNN are a version of neural network for different sort of data. Just I want to be very simple here. So we together have a relationship, right?
Mhm.
So you ask me, so do you want to interview in my podcast? And I say, okay, based on my relationship with host, yes, right? So
Mhm.
my brain remembers something. So there's a sequence of data. If the data has a sequence, then you cannot go with the simple RNN. You have to with a simple neural network. You have to go with the recurrent neural network. So therefore, in a recurrent neural network, you are working with sequence of data, time series, for example. So you have a bunch of neural network. They are connected and they share the hidden state each time together, just to give you more information on what happened in the past and what you need to do right now. So, and that's so, and when we talk about the CNN,
Mhm.
the same thing can be done. So RNN can be a 1D of CNN, right? 1D, but the CNN is the holy network for the community. It's very powerful, honestly, but powerful for what? For visual kind of processing, for image, for video, you know. And it's instead of in the CNN, everything is about the kernels, the filters that you train. So the network learns the filters and the kernels between the input and output. And basically, CNN says, I have to minimize the amount of connection between the neurons to be able to solve the problem. And that's why CNN is much more powerful than neural network itself.
Mhm.
And also that another fact that, you can go with a 2D picture. You don't need to convert for the neural network. You have to convert it with a vector. So you remove all the spatial relationship. But with the pixel, for the pixel level, it's good to have the spatial and also the time. So that's why CNN becomes a very important, very powerful neural network. And now all these neural networks are suffering from a vanishing gradient problem.
Mhm.
It's like it's easy to push information from the input towards the output, but once you want to train the model and back propagate the error, then here you will get problem. That's why the architecture of deep learning is the most important part. And the architecture of deep learning is going to change in the next 5 years quite a lot, because right now we have problems with the back propagation. For example, they have introduced LSTM, long short memory term, for as a version of the RNN that has a gated structure, so you can control what information to go and what information to come in. So this is another but that's also has not yet solved the problem. We are still very in the very early stages, but architecture of deep learning beyond RNN, CNN, and actual NN will come in.
Just a quick question. Sorry to interrupt here. Can you touch on vanishing gradient problem, just for the audience that have no background in this? Can you touch on what vanishing gradient problem is, especially associated with, the recurrent neural network, as you touched on?
Yeah. So
I know it's
we
kind of hard
know.
to explain.
Yeah. So in RNN and in the time series, you want to remember as much information as possible, right? For example, in a problem that we solved together, we were looking about 2 minutes. Sometimes 2 minutes is very short for another problem. They are talking about 2 years or 2 centuries. Or when you write a sentence, you want to actually remember the entire sentence, right? Or even the paragraph, just to be able to predict what word to kind of show the writer at the moment. So this is where the complexity comes in. So when you train your model on a lot large of text, it's hard for the network to remember all the information going forward, and it's even harder. It's even harder when you have a mistake or you have determined one of the errors, right? And you want to back propagate this error to update the weights of all the neurons in the very early layers because of this error. But it can go 2-3 layers, and after that it will be vanished. There is nothing to be changed for the very first few layers, and that's what is called the vanishing gradient. So you cannot update weights correctly based on the error that you got for the entire for the entire layers. And that's why if you add more layers, it becomes more and more complex to train and to get the model out.
Got it.
I hope that I have explained well. So
that makes sense. I just wanted, because like a lot of the audience that we have don't have the extensive background in deep learning, especially some of the vanishing gradient problem associated with recurrent neural network, which, as you alluded to, that's why LSTM tries to solve that problem, but I just wanted
exactly.
to touch on that before we confuse the audience. That's good.
Thank you. Yes.
So you talked about, can you also touch on some of the applications of RNN and CNN in the oil and gas industry?
So in the oil and gas industry, we are all about time series, right? It's everything that we work on. We have a history about it. Then we know the model needs to know the history before predict the future or predict now. So RNN and CNN, because CNN also can be used for a time series. As you have a picture that the height of the pixel is 1, and then you have a lot of pixels, right? That can be time. So the same scenario of the CNN or the same algorithm can be used also for, and it has been successfully actually applied for time series, but still not there. Not both RNN and CNN have problem still with the time series, especially if you want to forecast future. This is going to be very hard for them. Sure. And yeah, for example, so we are working, for example, in a hydraulic fracturing. So we have pressure data versus time. every single second.
Mhm.
So, and with that pressure, we can solve or manage a lot of risk, right? This is where RNN and CNN can help us.
Mhm.
And from another perspective, we CNN can be, so for example, we get the seismic data. It's a time series, it's a spatial series, right? It's like imaging, right? Very, very similar to imaging. So we can use CNN
Mhm.
here to do the seismic interpretation.
Got it.
And we have so many other examples that we can use those models, but the models are not yet there. You have to work on the models first somehow, or change the models, or use an assembly of those models all together to be able actually to solve one problem that we are interested in.
I got you. I got you. So within the RNN, there's an algorithm called, long short-term memory. Um, Can you touch on, a little bit about what LSTM is, and maybe some of its application? I think you alluded to one of the applications of, predicting hydraulic fracturing surface treating pressure, for the next minute or 30 seconds or so to make to be able to make important decisions, ahead of the hydraulic fracturing, but can you first touch on what LSTM or long short-term memory is, which is of course a subset of recurrent neural network and some of its applications and why it was like developed,
Yeah, so LSTM, as you said, is a form of RNN, or a recurrent neural network, that replaces the hidden layer neurons of the RNN with a unique subset of memory cell. In that memory cell, you filter information through a gated structure,
Mhm.
and that you have a very good control of the gates, what to forget, what to not forget, what to back, you can do a lot with that. It's a lot more advanced than RNN. But the application wise, again, they're the same. It's just, the algorithm that's a new generation of the algorithm. This is what we have to be working on. This is
Right.
what we need. Okay, for that sort of problems, the gate structure should be like this. And for that sort of problem, the gate should be like this, right? And that requires a lot of knowledge of the algorithm and a lot of retraining and training to understand what exactly they do.
Mhm.
So it's time-consuming type of application. We have to be very patient when we apply them, because you might get in the first try you might get a good result, right?
Mhm.
Let's say you're lucky and you just set an architecture that is for some reason is perfect for that problem, then you get it done. But if you just go out of the space again, the model doesn't work.
Mhm.
So that requires a lot of really back and forth. And again, this is a time series. It has been developed for time series, and all the examples that we discussed.
Got it. Got it. So can you touch on, so we talked about what some of these algorithms are, and I want to also touch on shortcomings. Of course, deep learning does have some shortcomings. And can you touch on some of the shortcomings of deep learning for the audience?
Sure. The neural network concept is a very simplified mathematical solution.
Hmm.
It's not a magic box people are talking about. It's very simple mathematical fitting equation, right? It's a very brilliant actually solution, but the architecture is not yet there. So right now, for every single problem that we solve, we have to come up with the architecture. So if we go that route for 10 years, for every single move, we have one neural network, and the computational cost will become a lot more than what we do right now, right?
Got
Because we
it.
have to train, and they are when you talk about the deep learning, and true training means a lot of computing power,
Yep.
right? That's why they are moving toward GPU and to make it simpler, faster, and cheaper.
Mhm.
So one of them is this architecture problem. So there is no universal architecture that we can use it and can feel comfortable that for every problem it gives us a very good accuracy. So for every single one we have to sit down, it's start from the scratch and go all the way to what you have. And just go out in the internet, think how many successful deep learning model are out there. except those for self-driving cars that are using the CNN, where they produced CNN for that purpose successfully, and that's why they are successful. The others are really not there yet. They're doing well, but 70%, as we discussed, 70% accuracy is good probably for some application, but for us it's not. It's really not. So if I want to say three main in addition to the architecture itself, okay, three main problems for deep learning or shortcomings of deep learning at the moment is that they are very tough to be trained. They require high quality data, often unavailable in our industry. And I've seen some people, and Shahab also actually touched on, people use the equations, the patterns that we already know, generate lots of data, and then they want to train their network and to kind of fill the gap with that equation and say, okay, now go ahead. Because we already have a pattern, and then you say, okay, my model worked because I already know the best pattern and the simplest pattern for it. That's not the pattern that we found. So I
You
already
already
know
have
the
pattern. Why you want to find more pattern?
Yeah, exactly. And then your model is still 98% of the pattern I already have. I have the 100% pattern. So why I should believe in your 98%, right? So, so if we want to be smarter, we need to have more sensors. We need to understand more the data, how to combine the data. This is the next revolution, is the fusion of those data, right? The sensor, they call it sensor fusion, that has to come in our industry. I mean, it's been engineered and applied somewhere else successfully, but when coming to our industry, we need to have more data, more high quality data. And then the last one to me is, it is extremely hard to build sophisticated background knowledge into the architecture of the deep learning. And every single person, including myself, we talk about physics-based. Most likely, the two way to do it is just to change the loss function a little bit, or just to play with the features a little bit. But these are not really building the knowledge into the model.
Yes.
Because right now we don't have a tool to do that. We don't know how to do it. We don't know it. So physics-based, science-based, all these names are just buzzwords, and we are not there yet. So we have to work towards them. So these three to me are the most complex, honestly, shortcoming of deep learning.
Got it. Okay, good. These are very, very good points, actually, especially touched on the the architecture, touched on the, we need more data, of course. I think the architecture is pretty important because, there's so many hyperparameters that you can change within a deep learning model that, could really change your answer. As you said, it makes it really hard to train it, so that's a big
And
problem.
assume that, and also even if you find it, all these hyperparameters, and again, that's for one problem. You solved one problem. You cannot be used for another problem.
Sure.
So, and now imagine how big, how complex is this, and people are really either do not think about it, or they have not yet practiced that because of they're just talking about things. So it's very complex. So we are not for the deep learning is very powerful. Deep learning, if we can have a universal architecture that solves complex, heterogeneous, multi-dimensional data, then yes, it's going to be a revolution.
Got it. So which areas of deep learning are you mostly bullish about, within the energy sector?
I just discussed that. So the architecture. The architecture is where everything actually will change, or it will help our industry to grow. Otherwise, so for example, in the energy sector is very big. So when I talked about the entire this interview is all about scientific data. I'm not talking about the business data, operation data, because we might have very good data and I have not practiced those. I'm just talking about the scientific. And if we have the good architecture, if we know how brain works, because our brain takes all the sensor data and process at the same time, this is sensor fusion, right? If we can rebuild that, of course, then we can learn almost anything. So we have to know the architecture, and then we have to know the data very well before modeling or before anything else. So
Got it. Got it. And then also, I know you've been involved in some cloud application. Can you touch on applying some of these deep learning models, assuming they're good, on the cloud, and you know the necessity for using the cloud when applying some of these models?
Yeah, cloud here is a cloud has been around for other purposes too. So it's just the word cloud is just to make everything scalable easily. So previously, when you wanted to build a software, you, for example, I'm talking about 20 years before AWS or Google Cloud, you have to do everything yourself. Then you created a software, then you had to, distribute it somehow between people to use it like in DVD and CDs. Now, these pipeline have been, revolutionized. You do your training, you do your model development, software development, everything on the cloud. It's already built in a lot of feature, a lot of services, so you can easily, it's to me it's a distribution channels.
Mhm.
Of course, it's very important. You don't need to monitor or have your own servers anymore, right? It's very expensive. You have to have people for that. You just go on AWS, for example, or Amazon or Azure. For example, in your training, you need multiple computers at the same time. You just spin up more servers, write your own work, do your own work, and then just shut them down. And then you pay for the amount that you have used. This is the way I see cloud, but cloud is much bigger than this. A lot of features and new services comes in. For example, right now, every morning that we get up, we see some of the software in our phone has been updated. It was impossible previously, right? But right now, through the air, we can do all the updates. We can, everything can be done much easier, much simpler, and everything is scalable. So let's say you have written a very nice application, and as of a sudden, 1,000 people, 1,000,000 people will want to use that service. So
Yeah.
if it was your own server, it took you a year to kind of be able to answer all those demands. But right now, it's just the numbers. You just put the numbers, for example, 10 servers, no 20 servers, or you can actually code it. It's just whenever you need it, whenever the demand is higher than what you have, then just spin up more computers on the AWS. So it's all about the scalability.
Scalability. Yeah, that's a very good point. And I think that's one of the biggest advantages of using the cloud is just the scalability makes so much sense that you can, as you said, you have 100,000 users versus 1,000,000 users versus 5 million users. You can, rapidly scale that
Exactly.
model. That's very good. So to wrap it up, can you talk about, I always ask this question towards the end, the future of AI is, if you had to fill in the blank, what would you say it is?
Will be amazing. It's
Okay.
amazing. Yeah.
Short and sweet.
Yeah.
And then any final thoughts and advice that you have for people that are, starting out?
Yeah, it's just AI is a tool. Like many other tools that we have seen in our engineering life or in our life, has a time span.
Mhm.
And short, it will be taken out by a new other technology. So we don't need to be extra excited. We just need to be very wise about it.
Mhm.
Whether it can, to me, many people are extra excited about it. They think AI is magic, but it's no, it's a tool, and we use it as much as we can. If we know that that doesn't fit my solution, I don't need just to force it.
Mhm.
There are other tools that you can smartly solve your problem.
Mhm.
So, but learn AI because it's gonna change the way we think,
Mhm.
but it will take time. It will
Sure.
take time. It's coming very soon, hopefully in the next decade. The way, and it's interesting that maybe in the next decade, the way that the AI algorithms are will completely go away, and the new generation comes in.
Mhm.
That's not something that we are bounded by simple ML or neural network to solve almost everything.
Mhm.
No, it's coming, and just be updated, work on it slowly, be patient about learning, learn the math behind it as well. Because you need to know what this, for example, if you apply LSTM, you need to know what does it mean, what this gated structure does it mean, right? What they have been built for. So this way you can architect, at least for your own simple problem, you can architecture the best model that you can solve it. And personally, if I would like to actually work on the AI space, and the space that I would like to actually work on is to solve PDEs, because I'm an engineer, I'm a scientist, I really believe in PDEs, in still partial differential equation. That's what I'm talking about. And so if I can, work and contribute in that field, that would be, something that I will go personally.
Nice, nice. Thank you very much. It's very informative podcast today. Again, Dr. Salah, it was a pleasure and honor to have you. Thank you for taking the time of your busy schedule. I know you've been very busy to do this podcast with me. I'm sure the audience will also appreciate it. If you have any final thoughts to say, I would love to hear from you.
Yeah, thank you so much, Haas. I think that was a very good session, even for me. So you can also write down my email in the description of the email if people have, if you're against what I said, because that's all personal idea. It's not, general idea, and I'm not imposing anything here. It's just what I think, and based on the 5 years, or actually 10 years, if we account the grad school as well, 10
Yeah.
years of this, working with this technology from the time that it was. Honestly, I remember a time when I discussed about fitting the data with a mathematical equation. It was bad at the grad school to talk about. You just fitting that. There is no physics in it. You cannot explain the data physically. You cannot write an equation for it. You cannot develop an equation for it. The time that I was doing, so I was hearing those things, and now everybody's talking about, no, AI is great. Just fitting probably is enough. You don't need to know everything about the model, or you don't need to use physics-based equations to define every single phenomena. Sometimes fitting is enough. So people right now believe in that. That's good.
Yeah. I know you're pretty also active on LinkedIn, so I'll put the LinkedIn information as well, so people can connect with
Absolutely.
you and ask you questions. Yeah, thank you so much for being here today. And anybody else, thank you so much for joining the podcast today. We hope you liked it. If you did like the podcast, please like and share and comment, so you can let the LinkedIn and YouTube algorithms do the rest of the work with
Thank you.
slight accuracy. Thank you so much.
Thank
Bye
you.
bye. Yep.